This video is for Math 111, and this is a discussion about the second project. So to start us off, I just want to point out towards the end of chapter 2 we talked about building, or actually somewhere in the middle of chapter 2, let's say this is 4 here, we talked about building factors from roots. And so we said that, you know, if this was -1 and this was -7 and this is 4, then you could build a polynomial by setting it up as its factors as x minus 4 times x plus 1 times x plus 7, right? So that the solution x equals 4 gives you a factor of x minus 4 and so on, okay? Okay, so that same idea comes up in this project at the very beginning. What we're talking about here is we're talking about a parabola with no real roots. Okay, notice I've drawn it so that it's above the x-axis. That means there's no real roots. Anytime you have a parabola that has complex roots, it won't intersect with the x-axis, right? If you remember back in chapter 1, I had these diagrams, you know, showing the 2 real roots and then 1 real root where it comes down and touches, and then no real roots when it's above the x-axis. So that's what this project is all about, is a parabola that represents a quadratic equation with complex roots. So if we identify these roots as p plus iq and p minus iq, then we can build an equation for the parabola as k, and that's going to determine how skinny or wide it is. And then with the roots, we'll do x minus p plus iq, and then x minus p minus iq. And then we can distribute those minus signs, minus p plus iq. Okay. So the first part of the project asks you to show that this expression right here can be simplified to y equals k times x minus p all squared plus q squared. And a way to do that is by distributing. Okay? There are a variety of ways. There's a shortcut thing you can do here if you want to. But in any event, distributing the x over here, distributing the minus p over here, distributing the minus iq over here, you should get terms that pretty quickly will resolve into something that looks like this. So that's the first part. The second part talks about the parabola being upward facing, right? If this k is a positive number, that means the parabola is going to be facing upwards. And y is going to be greater than kq squared. You get this line right here where y is kq squared. So all the y values will be bigger than that. And that's pretty typical for a parabola. They have this minimum y value down here. So in part 1b, we've got the x-coordinate of a parabola. If it's written out as y equals ax squared plus bx plus c, then your vertex, the x-coordinate for the vertex is going to be minus b over 2a. And there's a variety of ways that we can show that that's true. I'm not going to go into them you know, on this project, but it is kind of interesting. And so to get the equation into this format right here is going to be one of these kind of intermediate steps between here and here that you did in part 1a. Somewhere in there you should have something in this format, and you can pick out the b, you can pick out the a, and you can calculate the value of the x-coordinate of the vertex. Now, I say calculate and value, but these are going to be in terms of p and q, okay? So we're not going to have numbers in part 1. We do that in part 2 of the project. So part 1 is all abstract, okay? It's all about the K, the P, the Q, and so on, all right? So find the X coordinate of the vertex, and then you can plug it back in here, and you can find out what Y is going to be, all right? So that is part 1B, is finding the coordinates of the vertex of the parabola. Okay, then in part 1C, let's see how I start that out here. Yeah, where is Y equal to 2KQ squared? So here, this value of Y is KQ squared. Somewhere up here is going to be Y equals 2KQ squared. And the idea is we want to find a way to represent the X coordinates that match up to Y being 2KQ squared. And the way that you can do that, set 2KQ squared equal to the equation for the parabola and solve for X. Okay. So, again, you're not going to get a numerical answer, but you will get an answer in terms of K, P, and Q. All right, so in part C, this is the setup that you want to use. I highly encourage you to divide on both sides by K and then subtract Q squared on both sides. It's actually pretty straightforward. It looks a lot more intimidating than it actually is. Okay, so that's part 1, is to show that those two expressions are the same, right, by distributing and then consolidating. Part 1B is find the vertex, find the X and Y coordinates for the vertex. And then part 2C is find the X values that will make Y equal to 2KQ squared. And so we just plug it in there and solve this. Dividing through on both sides by K is a big, important first step there. Okay, now let's talk about part 2. So here's where we have an actual parabola. In this case, we're working with 2x squared minus x plus 5 equals 0. So like we did when we were doing that solution by graphing here, we're going to graph this. Well, we don't necessarily have to graph it, but that's the idea, is that we want to solve this equation by graphing it. And then let's see here. So find the value of x and y at the vertex. So here's minus b over 2a. Calculate the value of x, plug it back in, and that'll give you a value for y. Okay? So that's, let's see here. Part 2a, find the vertex. Okay? Now, if you go back into part 1, where we calculated the coordinates of the vertex, now you'll have numerical values for this vertex. Set them equal to what you found the x and y coordinates of the vertex to be in part 1, and that will give you values for p and q. All right? As always, when I'm talking about these things, they make way more sense when you've actually worked through the project, okay? As I'm talking about this, it can get kind of overwhelming. But that's part of the point of the projects, is this, I don't want them to be something that you can do in half an hour or something, all right? This is something that you kind of have to sit with and think about. So you might want to like work on the project, like do part 1, right? Watch the video for where I'm talking about part 1, do part 1, then come back, start in on part 2, and look at what I'm saying about part 2 as you're working through it. If you just sit here and watch me talk through all of this, some of it may make some sense to you, but really it's most valuable as you're working through the project. And as always, if you have questions, please let me know about it. I'm happy to talk about these projects. Part of the reason I give them is because I really enjoy these problems. I think that they're really cool, and I enjoy talking to people about them. Okay, so part 2A, find the vertex for this parabola right here, and then use that, based on the information that you got in part 1, to find the values of P and Q. All right, that's part 1A. Part 2A. Part 2B, double the y coordinate of the vertex. That's where we go up here to 2kq squared. So you'll have a numerical value for the vertex here in terms of x and y. Double it, that'll give you this 2kq squared. And then use the graphing software to graph the parabola and the line y equals 2kq squared, whatever that happens to be. You'll see these intersections right here, and the idea is we want to find these x values. Okay, let's see here. Right, value of q, right. Find the values at which the horizontal line intersects the parabola, either algebraically or by using the graphing calculator. You can find these intersections pretty quickly. The graph software has that capability as well. Reconcile these values with the values you found for P and Q over here. So this relates to part 1C, right, where we were finding the values of these intersections in terms of P and Q. Now over here we're going to have numerical answers, and you're also going to have numerical values for P and Q, and I just want you to show that they match up. Okay? Alright, so now that we've done all of that, so let's see, this is part 2B. Part 2C says, use the values of P and Q to express the complex roots. P plus IQ, P minus IQ. Typically, I put the I in front, but you know that like if P and Q were 3 and 5, you put the I after the number. So you're going to have values for P and Q, and all you have to do is do P plus QI, P minus QI. That's part C. And then finally, part D. We've gone through all of this work to find these roots, all these different ways. Part D says, use the quadratic formula. Don't use your calculator. Work it out. Minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay? Show that they match what you found when you found the values of P and Q, and use that to express the roots P plus QI, P minus QI. Show that in part D, this gives you the same thing as you got in part C. All right, so that's it for the project. Like I said, it's a lot to digest all at once, and I don't intend for you to digest it all at once, okay? These projects are meant so that the more you progress through them, the more sense everything hopefully will make, and the more sense my explanations will make. I always see that in class where I don't mind. I do this kind of thing in the classroom when we're teaching in the classroom. Because people who've worked on the project, I'm happy to help them. People who haven't worked on it at all, this kind of stuff is not really that helpful to them. And so I don't mind talking about it. So like I said, start working on the project. Maybe, watch the video through once, and then as you're working through the project, go back and watch this again. The things that I say that didn't make sense the first time you watched it may make more sense once you've started working through the project. And really, if you get stuck, please ask questions, okay? TJ's running an online math lab. I'm available every day by email, phone, and Zoom to answer questions. Now, the Zoom conferences are once a week, but if you call me and really need to see me, we can set up a Zoom conference. So, the bottom line is, if you have questions, ask. All right, thanks.